Hello. Yeah, good evening, everyone.
Yeah, good evening, sir. Hello.
Hello. Hello.
Yeah, good evening, sir.
Yeah, good evening, sir.
You should give me proceed
So,
now.
shall we start, sir?
Yeah, please, sir.
Yeah.
Please,
Thank you,
please
sir.
proceed. Thank you, sir.
Yeah. Sir, can you please enable the screen sharing? Hello. Hello, Sandeep, sir.
Hello. Hello.
Hello, sir. Can you please enable the screen sharing?
Yeah, please, please.
Yes. Thank you, sir. Okay. So, once again, good evening, everyone. So, today we'll be discussing with the additives parts. What are additives? What are different uh, additives which are available for plastics, or we can say for polymers. So so to begin with, first introducing additives and talking about why additives are needed. If you can see from the slide, whenever we go for synthesizing a polymer or for manufacturing a new polymer, we generally have a polymer in its raw form. Okay, so this polymer in its raw form, it lacks some ability to serve in real life applications. Okay, so just take an example of a cake. Okay, a birthday cake. So as you can see, if you prepare a cake without adding some aesthetic appearance or without adding some flavoring substances to it, your cake will not sell easily. Okay, so similarly, for the plastics also, for polymers also, your polymer should serve well in its application or during its service time. So to enhance its serviceability, we generally add additives to the polymer. Okay, so that its properties can get enhanced. Okay. So mostly all the polymers, if you see, they are unsuitable for processing in its pure, or we can say in its unmodified form. Let's take an example of polyolefins. Okay, or polyethylene, polypropylene. Okay, so when they are subjected to environmental factors, so the oxidative degradation takes place. This oxidative degradation, it is due to the application or due to the subjecting your polyolefins to heat and pressure during processing. As we have seen that there are different kinds of processing like extrusion, injection, rotational molding, compression molding. Okay, so is uh, sorry, but I am hearing some noise from the background. If
Sir, I think Sandeep sir voice is sir.
okay, yeah, 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 he has muted. Yeah, yeah. Sorry for that. Okay, so polyolefins, when you process polyethylene or polypropylene, so during the processing, what happens due to the application of heat and whatever the pressure it gets subjected during its processing inside the barrel or inside the mold, so due to that pressure and the presence of oxygen into that vicinity, okay, so oxidative degradation takes place. Okay, so to prevent that, we generally add additives. Another example I can give you is about polyvinyl chloride. So, as you might have learned, polyvinyl chloride, it is a heat sensitive polymer. Okay, so as it is a heat sensitive polymer, its process it is processed with different heat stabilizers. Okay, so without heat stabilizers and without plasticizers, you won't be able to process PVC. So PVC generally, if you can see the application, it is the pipes, which can be rigid pipes or flexible pipes also. So for PVC to get it converted into that uh, pipe shape or into that application form, generally it needs to be processed without degrading. Okay, so to avoid the degradation, we generally add heat stabilizers as an additive to PVC. Okay, so basically, what is additives? Additives, we can say they are specialized chemicals which are added to the polymers, or we can say plastics, which improves their properties and makes them easier to produce. So they are generally used in very small quantities, but using in small quantities also, it can significantly change their properties, their behavior, their appearance, and also its lifespan. Okay, so if we talk about the purpose of additives, first we can say it is to alter or to change their properties. So like taking an example of uh, to make plastic more flexible, more stronger, and we can say if it is being required to serve in outdoor environment, so in case of that, that plastic it should be resistant to sunlight or different outdoor environmental factors. Okay, so in this way we can alter the properties of your polymer. The second purpose is to facilitate processing. So again, additives can help the material flow better. Additives can help to material flow better during the manufacturing or prevent it from sticking to different machinery.
Your voice got muted.
Hello, hello,
Not able to hear your voice, sir.
hello. Yes, can you hear now?
Now it's okay, sir.
Hello. Okay. Yeah. So I was talking about facilitating the processing of the additives. Additives helps in facilitating the processing of the polymers. So it helps the material flow better during the manufacturing or processing, and also it helps or it makes sure that your polymer or plastic, it does not stick to the machineries while processing. Okay, and it should come out easily from the barrel or from mold. Then uh, third we can say it is about changing the physical, chemical, or electrical properties of the end products, which I've already talked about in altering the properties. Then reducing the cost. So fillers and other low cost additives, it helps in reducing the amount of expensive base polymer which is needed. Like in the previous class I have given you example about the, while talking about the composite and fillers. So at that time I have given you example about how it can help. There are different composites which are being added or loaded with the different fillers. Okay, so these fillers, they help in reducing the cost of the material by reducing the amount of the base polymer. Base polymer means whatever polymer you are incorporating your additive in it. So let's say for uh, in polypropylene, if you are adding some filler, so you are trying basically reducing the cost of the polypropylene. Okay, so requirements of additive, why they
But,
are needed.
sir, but when we add any additional additives, it is going to add cost to the base material, no? How, in what way that it will reduce the cost?
Yes, it will. See, fillers will reduce the cost. I'm not talking every additive will reduce the cost. So when we talk about reducing the cost, basically fillers play an important role in reducing the cost. Okay. So fillers are again one type of additives like calcium carbonate, then this uh, carbon nanotubes. Okay, so these fillers, they can help in reducing the cost of the material by increasing the volume of the material. Okay, so these fillers, when incorporated in the formulation, you, while incorporating, the composition or the concentration of your basic material, it is being reduced. Okay, so let's say if you are preparing 100 kgs of material, so in that 100 kgs you add 70% polymer and 30% your filler. In this way, so basically overall you sell 100 kgs of material, 100 kgs of polymer, in which you have 70 kgs of polymer and 30 kgs of filler. Okay,
But it
so
will not spoil the strength of our parent material.
no, it will. In fact, it will add, or it can increase the strength of your parent material. It will not deteriorate the strength of the material. So what happens at this formulation level? You add different materials, or as a basis of PHR, like parts per 100 resins of materials, or we can say in weight percent also. So as I have mentioned, if you are preparing a 100 kgs batch, so you will be adding 2%, 3%, 5% of additives, and accordingly your batch will be adjusted.
And this addition will happen as a post-reactor process like compounding, or it is in the reactor itself, sir?
No, during compounding itself, during compounding itself,
Oh,
you will have a virgin polymer, and with that virgin polymer, you will be adding the additives at different concentrations.
okay, okay, sir, okay.
Okay. Okay, so now why actually additives are needed. So if we see pure polymers, they often lack certain qualities as we have discussed previously, and they are needed for the end use applications. Okay, so like during processing, they might degrade, or they can become brittle, or they can also react with air and moisture. So therefore, these adding additives, it can make the polymers suitable for specific uses and improve handling during the manufacturing process also. So examples when I can talk about is the like polyolefins. It can have a degradation issues, like they can go oxidative degradation where heat and pressure can cause them to break down and lose the qualities. So to solve this problem, antioxidants as an additives are added. Another again I have, which I have mentioned about PVC, as due to its heat sensitive nature, it can decompose and release harmful gases, and therefore adding heat stabilizers as an additive can prevent the decomposition, and it can ensure safe PVC products. So for additives, first their function is, or the requirement of a particular additive, what an additive should do or what it is expected to do. The first thing is that effectiveness in their function. That means for additive to be effective, they must be stable during the processing and usage also. They should be compatible with your polymer matrix also, so that they do not separate. So like there are some additives which when added into the polymeric material, after a few hours, those additives they migrate to the surface. Okay, and then the polymers, due to the incompatibility issues, your polymers or the additives do not play its function. Okay, then not to be volatile, your additives, it should again not to be volatile, or neither it should again migrate or extrude through to the surface. They should neither bleed nor bloom. Okay, and they should have low vapor pressure at high temperature. This means having a low vapor pressure ensures that your additive will not evaporate very quickly even at high temperatures. Then your additives, it should be non-hazardous, it should be non-imparting taste and odor, so it can avoid unwanted colors or odors in your final product. Okay, now for food grade polyethylene, which is generally used in food containers, additives like antioxidants are added and some slip agents are added. Okay, so these additives should, it should be non-toxic, odorless, and it should be able to withstand the heat without altering your food containers or your food packaging properties. Okay, so now you have the classification of additives. There are different additives. Okay, so additives can either be classified based upon these different roles which they will play. Like first you can see is assist in processing. So assisting in processing, we can generally say these are mostly these processing stabilizers or lubricants. Okay, so these processing stabilizers, it prevents the polymers from degrading when they are exposed to heat and oxygen during production or during the processing. Okay, because these processing added stabilizers, they stop the oxidation process, which generally leads to discoloration and brittleness. Then again, lubricants, lubricants which can be external and internal also. So these lubricants, when added during the processing, it helps in reducing the sticking of your polymer to the metal surfaces. It again helps in reducing the friction of your polymer to the metal surfaces during processing. Then modifying the bulk mechanical properties is another function or aspect. So in modifying bulk mechanical properties, we can have plasticizers. So plasticizers, they generally act, or they generally help in increasing the flexibility or imparting the flexibility to your polymeric material. Reinforcing fillers, as we have discussed during the composites class, reinforcing fillers are nothing but the fillers which add or which acts as a reinforcing agents, or we can say which imparts the mechanical properties or strength to the material, like glass fibers, grass fibers, okay, plant fibers and animal fibers, which we have discussed in the previous class. Then there are toughening agents. So again, toughening agents, like there might be some elastomeric polymers or some impact modifiers, we can say. So these modify your overall bulk mechanical properties of your polymers. Then again, when you try to reduce the cost, you generally go for selecting the fillers. So these fillers, as I previously mentioned, fillers can act in reducing the cost of your base polymer. Then you have diluents and extenders. So what are diluents and extenders? We will see in the coming slides. Then you have surface properties modifier. Okay. Now there are some polymers or plastic materials which require, or where the surface properties are of utmost importance. Let's say, for example, in packaging of electronic items. Okay. So while packaging electronic items, the plastic film, it should be anti-static. Okay. So what happens, as plastics, they are an insulating material, insulators, so there is a highest chance of developing a static charge on your plastic film. So to reduce that, anti-static agents are being added. Okay. Or you can say there are some adhesion promoters. So let's take an example of polypropylene. Okay. So for polypropylene, you will find that it is difficult to print on the surface of the polypropylene. So to improve its adhesion properties, we generally subject it to different surface treatments like corona treatment, plasma treatment, and all. Okay. So likewise, there are some other polymers which require different surface properties to be enhanced, which require surf the plastic materials or the polymers which needs to be stick to the metal surface or to another polymer surface. So to enhance its adhesion properties, adhesion promoters are being used. Then you have optical properties modifier. So for optical, when you are trying to target optical properties, generally use nucleating agents and different colorants. So colorants, they generally serve in imparting aesthetic appearance to your final product. Then anti-aging. So as there are the polymers with a certain lifespan. Okay. So to increase their lifespan, during overall their lifespan, every polymer, they generally age. Okay. Due to their typical outdoor and indoor environmental factors, due to the surface, due to the moisture, humidity, you can say, or due to the uh, rain or UV light, okay, or oxygen presence. You can say. So these properties, these polymers, they generally age over a period of time. So to increase their lifespan, generally anti-aging uh, properties are being targeted. So for that purpose, you mainly UV absorbers and fungicides are being used as an additives. Then there are miscellaneous additives, we can say, or miscellaneous properties like blowing agents, which we have discussed in the case of polyurethane foam. So in polyurethane foam, you have different blowing agents. Okay. Apart from polyurethane, you have different polymers like polyolefins, polyethylene or polypropylene. So in that case, you use different blowing agents like this azodicarbonamide, okay, or sulfone based blowing agents. Then flame retarders. Flame retarders is again one type of example. So flame retardants are generally added when you target to increase the flame resistance of your material, okay, or when you try to reduce the flammability of the material. Okay, now talking
What is
about the
sir, what is the chemical added for that flame retardant?
for flame retardants, the basically previously uh, antimony based products were added, are being added in. There are organic and inorganic flame retardants, okay. So when you talk about inorganic flame retardants, generally phosphorus based flame retardants are being added, or ammonium polyphosphates, we can say. That is one example, ammonium polyphosphate. Then previously halogen based flame retardants were being used, like if you see polyvinyl chloride, due to the presence of chlorine atom in polyvinyl chloride, it also gives the flame retarding effect, okay. But the chlorine atom or the halogen which is being present, it generally affects the properties of your material and it impacts the environment, okay. So to avoid it, now mostly the brominated or non-halogenated flame retardants are being used. So different flame retardants and their examples I have included in the coming slides. So we'll discuss them in the coming slides. Okay, now talking about the processing stabilizers. Now, processing stabilizers, they are nothing but they prevent polymers from degrading when degrading due to the heat and oxygen. Okay, so how how they can protect? They stop oxidation process. Okay, so due to the presence of oxygen along with heat, okay, your polymer, it undergoes oxidation process, and this oxidation process, it leads to discoloration and brittleness of a product. If you see from in the image here, you can see, or you might have also observed the PVC pipes, okay. Over a period of time, your PVC pipes color, it fades, okay, somewhat yellowish it becomes, as you can see in this picture, okay. So this yellowness is due to the oxidation. This is which we call it as a discoloration, and along with it your polymer, it also becomes brittle, okay. So generally during this degradation process, your the oxygen which is present, it combines with the polymer to form carbonyl compounds, and these carbonyl compounds, it leads to yellowness and brittleness of a product. So if you see, there are different processing stabilizers. First is like primary stabilizers, which we call it as an antioxidant. Then secondary stabilizers, peroxide decomposers. Third is the chelating agents. So fourth is the special stabilizers, which we call it as a heat stabilizers. It is generally for halogenated polymers, as previously I have given you example of the PVC one. So if you see the primary stabilizers, these primary stabilizers, they stop the free radicals which are formed by heat and oxygen. Okay, so free radicals are nothing but they are the chemical species, or we can say the molecules which are highly reactive, and due to their highly reactive nature, they disturb the polymer structure, they break the polymer structure, and they form a disturbing structure. Okay, like some common antioxidants which I can mention here is hindered phenols and some aromatic amines. Now, when you talk about secondary stabilizers, so these secondary stabilizers, they help break down the harmful peroxides. Okay, so harmful peroxides are nothing but the molecules which HOO group in it. Okay, so or we can say a peroxide group in it. So these peroxide group, it again it is a reactive one, so it degrades the polymer. Then chelating agents or metal deactivators. So metal ions which are generally being present from the catalyst. Okay, so you can, from where does this catalyst come? During the synthesis of your polymer, there are different catalysts and initiators which are being used. So for example, for polyethylene, Ziegler-Natta catalyst is being used, in which metals are being present. So these metal ions which come as a residue from uh, the synthesis reactions, they can accelerate the degradation of your polymer. Okay, so chelating agents are being used. So these chelating agents, they bind to these metals, and after binding, they neutralize the harmful effects of these metal deactivators. Okay, so like examples of some processing stabilizers which I have given was hindered phenols, some thioethers, and some phosphides. They can also be used as an antioxidants in polyvinyl chloride. Now talking about the antioxidants, so antioxidants, they are the primary stabilizers. Okay, or these stabilizers, they can prevent the oxidative degradation by interrupting the chain reaction. Okay, when a polymer is being exposed to heat, light, or chemical reaction. So these antioxidants, they combine with the free radicals which form the non-reactive products by stopping the further degradation. So examples of these antioxidants, we can say uh, one commercial material or commercial additive I can give you example of. I think it is from BASF. It is Ergonox 1010. Okay, so generally this Ergonox 1010, it is used in polypropylene and polyethylene, where they inhibit oxidative damage and it prevent discoloration and brittleness. Then you have some aromatic amines which are being added to the polyurethanes. Okay, now the effect of oxidation. When we are talking about oxidation, we can just discuss what is the effect of oxidation. So due to oxidation, what will happen? You will lose the tensile properties, okay, or we can say the mechanical properties, or we can say the strength of your material. Okay. Then again, you can have a discoloration like yellowing. Then increased brittleness. As you can see in this picture, it is a brittle failure of the material is cracked. Then melt flow instability, then change in appearance. So this is how your polymers appearance might change. First the gloss was good, and after the degradation your material it lost its gloss properties. Or you can also say the loss of transparency properties in this picture also. Okay. Then cracking, again cracking is also being induced due to the as an effect of oxidation. Okay, so secondary stabilizers, when we call it as secondary stabilizers, generally as discussed, these are the peroxide decomposers, we can also say. Or these secondary stabilizers, they reduce, or they convert, we can say in simple language, they can convert the peroxides to alcohols. Okay, and after converting it to alcohols, they are just deactivated alcohols like OH groups. Okay, so examples of the secondary stabilizers, they are just sulfur and some phosphorus compounds such as sulfides, thioethers, or some tertiary phosphides. Then chelating agents, again just now which I have mentioned or talked about, preventing degradation by metal ions. So these metal ions are nothing but the impurities in polymers which are being formed as a result of the polymerization process. Okay, or different some fillers or pigments are being added, or like Ziegler-Natta redox initiators. So these Ziegler-Natta initiators or catalysts, we can say, these are being used but while converting your monomer to polymer. Okay, then when your polymer is being formed, some of the metal impurities are being left in your final polymer. So after converting your final polymer to a finished product, or during converting a final polymer into a finished product, it generally has a certain effect on the polymer properties. So these metal compounds, they might degrade or they might deteriorate the structure of your polymer system. So to avoid that, generally chelating agents are being added. So some examples of chelating agents are organic phosphines or phosphates, or some nitrogenated compounds like melamine, diamine. Okay. Now talking about the heat stabilizers. So heat stabilizers, they are nothing but they protect polymers like polyvinyl chloride from degradation at higher processing temperatures. And these stabilizers, they generally absorb harmful byproducts or neutralize the gases which are being released during heating or while processing your polymer material.
So, sorry to interrupt. So, can you give us some more examples? Like you told us that in PVC, these heat stabilizers are being used. So, apart from PVC, are there any other, polymers in which heat stabilizers are being used?
uh, Mostly PVC is the like prominent one for which heat stabilizers are also used, is being used. There are other polymers also depending upon your processing temperature. Like let's give an example of polyhydroxybutyrate. Okay, as polyhydroxybutyrate is again one of the biopolymers, so it has a narrow processing window, and it has a tendency to degrade at a shorter temperatures. So to again enhance its processability, we can also use heat stabilizers in polyhydroxy butyrates also. Okay. So depending upon your polymeric material system, your processing temperature, you can you can define or we can adjust which kind of heat stabilizers can be used in a certain polymeric system. So if you talk about PVC, PVC is one of the prominent one as it is a heat sensitive material. So what happens during while when you process the PVC? So in PVC, during processing, corrosive gases are being evolved. Like as you can see, HCl, for example, HCl is being evolved. Okay, when it is being heated and processed. So to maintain color, it prevent its material breakdown. Okay, so and to also absorb these corrosive gases, generally heat stabilizers are being used. Okay, so examples of heat stabilizers which I can give you for a PVC, it is lead based stabilizers. Okay, like dibasic lead phosphide or organotin based compounds like dibutyl tin malate or some calcium zinc compounds. So these calcium zinc compounds can be used as a safer and more eco-friendly alternative in heat sensitive applications. So synergistic stabilizer system, again, it is one of these systems where you combine where you can have effect of two or more stabilizers, okay, which is greater than the sum of the effects of the individual stabilizers. Let's say you are using stabilizer A and stabilizer B. Okay, so when you mix it or when you use it together, okay, so the effect which you will get by using both stabilizer A and B together, it will be very much higher as it would have given by using stabilizer A alone or stabilizer B alone. Okay, so this synergistic effect can be achieved by using two different stabilizer systems or two or more stabilizers. Then lubricants. Lubricants, it generally reduce the friction between the polymer chains and also between the polymer and machinery. So this will basically help the plastic flowing better during molding or during we can say extrusion or injection molding. So this generally results in the preparation or forming of a smoother surfaces, and it prevents the sticking of the material to the surfaces. So
Sir,
if you see,
will there be any reaction in the equations like polyvinyl chloride, yeah, benzene when then there is a chain, whatever we call no, the chain opening.
there will not be any reaction when you add the additives. So these additives they generally act physically on physical level. Okay, as I'm talking about, there are different polymer chains. So these additives they interact with these polymer chains. So this interaction is physical. It is not chemical interaction. Okay,
The
so
chain will not have any difference.
yeah, chain will not have any difference. There will no the the chemical structure of your polymer will also not change.
Then how the mechanical property or the property in the this thing polymer is improvised by this? If there is no imbibed into the chain.
Yes, a good question. So now, when we are talking about lubricant, so let me give you an example of lubricant. So as you can see, lubricant when they will external, they can be external or internal lubricant. Okay, so what lubricant will actually do, it will reduce the friction between the polymeric material and the processing equipment, right? So the physical interaction in this case will be like the external lubricant, it will create a thin film between the polymer and the metal surface. So this thin film, it will reduce the sticking of the polymeric material to the metal surfaces. Okay, so this is one of the external lubricant. Now again, if I talk about internal lubricant, so what will happen now in internal lubricant? Now there are different polymeric chain systems. Okay, so your lubricant, it will act within the polymer matrix, and it will act within your different polymeric chains, which will reduce the friction between your polymer molecules. So what will happen? Your polymer chains, they will slip over each other. Okay, or we can say they will slide over each other. This sliding will induce the flowability of your polymeric material, and due to this flowability, your flow properties of the polymer will improve. Okay, got it?
So these adhesives or this lubricant fillers, these will have a higher heat the resistance. This will have a higher resistance to heat, so that when we melt, it will not get reacted to our temperatures. This will
Yes.
act as a separate film between the polymers.
Yes. So as I have previously mentioned, what are the different under the category of what are the different requirements of additives? So one of the requirement I have listed out, it was that your additive, it should be thermally stable at whatever temperature it is going to be processed. Okay, so lubricants, or we can say there is another category of again additives which improves the flow properties. It will be discussed in the coming slide. So it is nothing but a plasticizer, or and we can also say it is a lubricant. Another one is lubricant. So these have a thermal stability at a processing temperature. These are thermally stable at a processing temperature of that particular polymer.
Okay, okay, sir.
Yeah. Okay. So, as I mentioned, external lubricants and internal lubricants, and I have, while given examples, I have also, or while answering to your questions, I have addressed your these external and internal lubricants. What are the different roles these external and internal lubricants play?
Right.
Okay, so
One more small doubt, sir. If there is no reaction, then homogeneity, how it will maintain over a bulk volume, a mass compounding, then the homogeneity plays a role, no? There can be a little in one side, and the other side can have a higher this thing compounding of lubricant or
okay,
filler.
you're talking about how well it can be dispersed in the polymer matrix, right?
If there is, as you said, there is no reaction, only the first case, primary something you told us, that will have a reaction with the free radicals. So others will not have any reaction, you told. If that will have a reaction, means okay, there is a bonding. The others will not have a reaction. So how homogeneity it will be?
See, now when we talk about reactions, now see, there are additives which can chemically react also, and which can physically interact also. Okay, so there are different categories which can react physically and which can react chemically. Now, previously, which I have talked about antioxidants. So, antioxidants, they were chemically reactive. Okay, in what way they were chemically reactive? They were not reacting with the polymer system. Okay, but as a result of the oxygen and the high temperature, okay, your polymer was or has a tendency to form a free radicals. Okay, or
Okay.
yeah, when they become thermally unstable, So they have a tendency to form free radicals. So your this antioxidant or the thermal stabilizers, we can say, what they do, they they quench that free radical instantly, so that your polymer structure, it should not get changed or it should
Oh,
not get deteriorated. Okay, so this is how chemical interaction plays a role in case of antioxidants. When we talk about lubricants or physical interactions, so there are lubricants, anti-slip agents, and these plasticizers. Okay, these are some examples which are additives which physically interacts with the polymeric structure and your matrix. Okay, now when you say that how well it can be dispersed within your polymeric matrix, when we talk about the physical interaction, right? So what happens, you have a range of certain materials which we call it as a compatibility. Okay, certain range of chemicals or certain additives which are compatible with our polymeric system. What they do, they just have a positive spreading coefficient, or they have a chemical affinity in which they properly get dispersed into your polymer matrix during compounding, during mixing itself. Now, let me give you an example of PVC material. Okay. Now, as I have mentioned about the plasticizer, it is a physical interaction. In polyvinyl chloride, to process it smoothly, we add a plasticizer called it as a dialkyl phthalate. Okay. Now, PVC, it is available in powder form. Okay. So, and your plasticizer dioctyl phthalate, it is generally available in liquid form. Okay, now if you mix it suddenly in an extruder, surely there will be issues of this dispersibility and wettability of your PVC powder. So to make it properly wettable, a prior blending is being carried out, or we can say compounding is being carried out. There is a certain mixer. In that mixer, your PVC powder is being fed, and in that PVC powder, your plasticizer is also being fed, and it is being mixed for few minutes, so that there is a certain time allowed for your plasticizer to wet your PVC powder molecules or PVC powder surface. So due to this action, we can ensure that your additive, it has properly mixed or properly well dispersed into your polymer matrix. Got it?
understood, sir. Blender they are using. Okay.
Ha! Blenders they are using. You see, in most cases, blenders they are using, mixers they are using, and in some cases, if blenders are not being used, so there are systems in your processing itself, and your chemical affinities also plays a role in it, or we can say compatibility of your additives. See, require I've in requirement of additives, I have discussed about the compatibility. Your additive, it should be compatible with your polymer material. So this compatibility, when the additive is compatible with your polymer material, it blends well and it properly disperses within your polymeric matrix. If it is not properly compatible, it will not blend and it will not give you that additive effect in your polymer. Okay.
Understood, sir. Okay.
Okay. So as discussed, external lubricants, obviously they prevent sticking the parts, metal parts to the polymeric material, sorry, polymeric melt to the metal parts. They have low compatibility with polymer but have higher affinity for the metal surfaces, so that they should have a tendency to form a thin film onto the metal surfaces, and they should stick to the metal surfaces. So if they have an affinity or compatibility more with the polymer surfaces or the polymeric material, these external lubricants may get carried away into your polymeric systems. So which can lose the tendency of your external lubricants to form on the surface as a film, and again it will, your polymeric material may stick to the metal surfaces. Then these external lubricants, again it improves the surface finish and gloss of your material. Some external lubricant examples are metal soaps, some hydrocarbon waxes, stearic acids, calcium stearates. Okay. Then internal lubricants. Now internal lubricants, it promotes the flow by reducing cohesive forces between the molecular interfaces within the resin. So these internal lubricants, they are generally a low molecular weight compounds which have a polar groups in it. Polar groups like uh, COOH group, OH group, okay, Eastern groups. So these, they function by reducing the intramolecular friction before and also during the melt formation, and this promotes the flow properties by reducing the melt viscosity of your polymeric material. Okay. So basically, it it acts or it penetrates between the different polymeric chains and reduces the friction between the different polymeric chains, thereby promoting the flow and reducing the melt viscosity. Some examples of internal lubricants are amine waxes, ester derivatives, some glyceryl monostearates, long chain esters,
So these,
or
sorry, so these internal lubricants are like mixed with raw materials during processing by the manufacturer, or these are supplied by the raw material supplier. Like, what is the process?
see
See,
what
what
happens.
happens?
Uh, Actually, I am having echo of my voice. So can you please mute? Okay. So what happens? The supplier, in some cases, the supplier might mix your polymeric material with this kind of basic additives. Okay. So if you talk about the suppliers, if you have a polymeric material in its virgin form, so in virgin polymeric materials, you might not have these internal lubricants. Okay, where you have a system. For example, you need a material for manufacturing pipes. So for pipes, they have their formulation, they have the material prepared for that specific application. You have different grades of polymer. So in that different grade, the manufacturer, it can give you the material with these internal lubricants itself, formulated with itself. Or in some cases, you might be required to add these internal lubricants so that it can ease the processing of your polymeric materials.
Okay, and just like you told us that external lubricants are also there. So let's
Yes.
say if I am facing a issue of material sticking, so in that case, there are some kind of materials which may uh, which may react with the external lubricants. So in that case, to avoid the sticking of the material with the metal surface of the cavity, can I use internal lubricants in place of external lubricants?
No, you cannot use internal lubricants in case of external lubricant, because if you see chemically, the structures, both internal lubricants and external lubricant structure is different. Okay, so due to the difference in the chemical structure, their role of function is totally different. So if you see here, in case of internal lubricants have different polar groups in it. Okay, so these polar groups they interact with polymer chains with secondary intermolecular interactions like hydrogen bonding or by inducing van der Waals forces. Okay, but if you see these internal lubricants, they might not have a tendency to form a surface film surface on the metal surfaces. And if you talk about an external lubricants, by using external lubricants, whether you can use it as an external as an internal one. So external lubricants they do not have these kind of structures like having a polar groups, and as due to the absence of such kind of groups, it cannot induce a intermolecular interaction between a polymeric chains. So these secondary forces or intermolecular interaction is necessary for reducing the friction between your polymeric chains and for also inducing the slippage between your polymeric chains.
Okay. And next question from my side is like there are some external lubricants which can react with the with some polymers. So how we can like check if if a manufacturer is using some kind of external lubricant and that is uh, reactive to the polymer or not? Like how we can take a preventive approach towards using the external lubricant?
I'm not getting your question clearly. Can you please explain it by giving a certain example?
Yeah. So what happens in some cases? I'm not sure whether it is ABS or PP. So there have been some instances where material degradation have been observed due to the usage of these external lubricants.
Okay.
So my question is, are we aware or is there any list through which we can identify that with what kind of what kind of external lubricants are suitable for which kind of polymers? Like, is there any metrics? Like, okay, if I am manufacturing a part with PP, so these kind of external lubricants will be compatible with the PP. This will be compatible with ABS.
Uh,
Any any data is
yeah,
available
yeah,
like
yeah,
that?
yeah. I've, I have understood your question. See, I'm not sure about how I can tell you that which kind of external lubricant is suitable for which kind of polymeric system. Okay, but when you talk with your these external lubricant providers, the technical person, he can very much greatly help you with the what kind of system is being suitable for your this PVC system, or we can say PP system or ABS system, whatever you are using.
Okay.
Yeah. So if now for polypropylene system, like if you see if PP is being processed, a film formation needs to be taken place. So generally, we need to see what kind of stabilizers or what kind of structures have been used till now for PP, and upon then zeroing down upon what kind of different stabilizers are being used. Sorry, external lubricants are being used. We can just narrow down on which can be suitable on which one. So so if possible, if we can have a lecture tomorrow, if like my additives part, if it remains today, and if we continue our lecture for tomorrow, I will surely come up with the answer to your question. Or you can what you can do, you can just drop an email to me, so I can just get back to you on that email.
So can we get your mail ID, please?
Yeah, please note. It is saddive.ajinkya.
Maybe can you put in chat box here so that we can copy?
Yeah, yeah, sure, sure, sure.
Sorry, I missed that communication. So what was that about?
Uh, Actually, I mentioned that as currently I am not surely, I cannot surely tell you how or which external lubricant system is feasible for which polymer. So maybe I can get back to you either in tomorrow's lecture, okay, if we have a tomorrow lecture, or you can surely drop an email to me so I think that I can just clear your doubt on email.
Yeah, yeah. Okay. Got it. Thank you.
Yeah, I'm just putting up my email ID on the in the chat box. You can just please note, and whatever questions you have, you can surely send it to me, and I will I will be very like glad to answer those questions.
Yeah. Thank you. Thanks for that.
Okay. So this is the personal email ID which I have put on. Okay. So just confirm whether you have received it or not.
Yeah, we receive. Yeah.
Yeah. Okay. Thanks.
One of my question, if whether this list what you are showing, no, in the previous slide,
Yeah.
amide is for nylon, ester is for polyester, like that I understand, and polyethylene, like any material related to polyethylene is the last to second. Should we take in that way? And if that is so, then fatty acid and amides, whether it is also for nylon 66, how we should consider?
Yes. Yes, you can consider in that way also, because what happens? See, as you can say, amides it have NH group in it, and again in fatty acids and amides you also have NH group and some hydrogen molecules in it. So what basically happens when your these internal lubricants penetrate between your polymeric molecule, it interacts with the polymer molecules through hydrogen bonding. Okay,
Okay.
so this kind of interaction it induces the flow properties of your polymeric system.
Okay.
Yeah.
So it is like first one is nylon, and the last to third is nylon. In between it is polyester. Then what is this glycerol monostearate?
Glyceryl monostearate. So glyceryl monostearate, it can be used in PVC systems.
That
Okay,
is used in
in PVC systems it can be used.
PVC. Long chain
Yes,
esters.
zinc stearates.
Okay. Long chain esters. If esters means it is a uh, thermo setting plastics. Huh?
Esters, it are the molecules or chemical molecules with COO linkages. COO linkages. Okay,
So
or the chemical molecules which have COO groups in it.
okay.
As we have seen about in this
If you can give
polyurethane, na? NHCO. In
understood.
polyurethane, you have seen, I have shown you urethane linkage, right?
Yeah.
NHCO.
Yes.
Yes. So likewise, in case of NHCO, you will have COO linkage. So in that case of molecules, you can say they are the long chain esters.
Okay, and that can get linked to this one. So this can be easily applied there.
See, long chain esters, it doesn't necessarily, we can say that it can be incorporated into polyesters only. It can serve well in PVC also. As polyvinyl chloride, it does not have any ester molecules. So even
Okay.
if you incorporate long chain ester molecules as an internal lubricants in PVC or in polypropylene also, so it can also serve its application.
Will it create a cross link or it will be a straight link only?
No. It is a linear chain. Sorry,
Link
long chain. Long chain, and it
cross.
is a linear one. So cross linking means it will just form a cross linked or 3D network with the polymer molecule. In this
Okay.
case, as I have mentioned, it is just physically interacting with the polymer molecules.
So can you give at least next time when you show this, no, or afterwards you can also send through mail. What is the equation for this amide wax and other thing, and where is the application? Like that, if you can give a table, it will be more helpful for us.
Okay, surely, surely, surely.
Thank
I
you.
will note down that. Yeah, and I will try to again email you. Okay, if you send me so that I can remember to revert you back onto that email. You
Yeah,
can
sure.
just, yeah,
I'll send an mail.
yeah. Okay. So, okay. Now coming to the plasticizers. So plasticizers, they are generally molecules which increase the flexibility, the softness, and the processability of your polymers. Now, they are generally responsible for making rigid polymers like polyvinyl chloride or polystyrene more flexible. Okay, so if you see, you might have seen in the commercial market, you have a rigid PVC जिसे RPVC भी कहते हैं, right? And there is flexible PVC also. So you can see PVC pipes which are rigid as well as which are flexible. You can also see PVC in cable applications also. So in cable applications, you can find PVC. It is a flexible one. So generally, these plasticizers, they reduce the glass transition temperature of your polymer, and it allows the polymers to become soft and pliable at lower temperatures by reducing the internal friction between the polymer chains. Okay, so do you know what is the glass transition temperature?
Yeah, glass transition temperature. That after that it become plastic. Metal become plastic.
Or we can say it is the
That will lose the
temperature.
property of plasticity. Yeah.
Yeah, so it is the temperature above which
It
your
is like
material.
from where
Yeah,
the material start degrading, melting.
no, not degrading, we can say.
Sorry, not degrading, melting.
It will lose the property of flexibility.
Yeah,
Yeah.
it will lose the property of flexibility, or we can say, no, not lose. It will your material, it will just become flexible below glass transition temperature. It will lose the property of your flexibility. In simple way, if we can say, the temperature below which your material, it becomes glass like rigid, and beyond which it becomes a flexible one. Okay, so I will not go technically into it. I will just try to keep it simple. So the temperature at which the material turns from glassy to rubbery. Okay, now let's say temperature of 50 degrees Celsius. Let's say there is a specific polymer which has a glass transition temperature of 50 degrees Celsius. Okay, so below 50 degrees Celsius, your material, it will behave rigid like a glassy, like glass, and above 50 degrees Celsius, it will be flexible one. So now, just to give you an example, elastomers, okay, or we can say rubbers. So what are rubbers? Rubbers have very low TG, like minus 100 degrees Celsius. They have a TG of minus 100 degrees Celsius. So above minus 100 degrees Celsius, it is flexible. That is why at room temperature also rubber molecules are very much flexible. Got it? Okay. Now, the when we add plasticizers into the polymeric systems, we generally have different effects like easy melting. The polymer it easily melts. Second is improving the flexibility. The flexibility of your polymer system it improves, or your polymeric system it becomes more flexible. We can say. Then the softness also increases. The processability or the ease of processing also increases, and as a result of this, the softening point of your polymer it changes, or we can say it reduces. Tensile strength it reduces. Elongation at break it increases, and its impact resistance in most of the cases it increases, and in few cases it decreases also. So again, there are the different types of plasticizers, where you have the primary plasticizer. So these kind of plasticizers they are highly compatible with PVC systems, and they can be used alone. Like as I've given you previously the example of dioctyl phthalate or diisoctyl phthalates also. Then tricrysyl phosphate is again one of the plasticizer. If I talk about natural plasticizer, so uh, glycerol. Glycerol is again one of the plasticizer, which is used for different polymer systems. Like take an example of starch. So starch is nothing but a natural biopolymer which is very much brittle. So to make it processable and flexible, it is generally converted into a thermoplastic starch by treating the starch with glycerol. So glycerol it acts as an, or it gives a plasticizing effect to your starch material. Then there are secondary plasticizers. So these secondary plasticizers they are less compatible with resin, and they are generally used in combination with the primary plasticizers. Like giving you an example of epoxidized soybean oil. So this generally it is being used as an alternative in food packaging and some children toys. Then extenders are nothing but the type of secondary plasticizers, and they have a limited compatibility with polymers, and in conjunction with primary plasticizers, it enhances the efficiency of plasticizers. Now, selection of plasticizers. Now there are different plasticization techniques, or we can say plasticization mechanism, like gel theory and all. So I might not go into detail in within those theories, but just for your reference, you can refer to these theories, so you can understand these effects and what actually is the solvating power in that case. So selection of plasticizer is generally basically on, you can select on the basis of the solvating power of a plasticizer, or we can say how well it gets penetrated or interacts with your polymeric system. Then its efficiency, whether it is being used, whether it is efficient to act as a plasticizer. Then its compatibility, whether it is compatible with your polymeric system. See, there are few polymers, like let me give you an example of dioctyl phthalate in case of PVC. So, or we can say epoxidized soybean oil. So, epoxidized soybean oil is one plasticizer which gives a plasticizing effect in few polymers like polylactic acid is one of the example. So if it is giving the plasticizing effect in polylactic acid, it won't necessarily give the same effect in case of polyvinyl chloride. Okay, due to the compatibility issues and due to the adsorption value also, or we can say the solvating power also. So different plasticizer system requires different polymeric systems. Then you have flame retardant, toxicity of a plasticizer, whether it is being toxic or whether it is harming the environment. Then whether it is capable for low temperature performance, and finally its costing. So these are all factors you need to consider while selecting the plasticizer.
But this solvating, can you please explain once again, sir?
Solvating in general sense, I will not say that you can just consider it as dissolving, okay, but just to make you understand, think it of as in dissolving, okay. Like, as you know, polymers, they have different regions like amorphous region and crystalline region, right?
Yes, sir.
So when a plasticizer, it interacts with this region, let's say for amorphous region, so how well it solvates or it dissolves that amorphous region or crystalline region, it defines the efficiency of your plasticizer. If it is solvating very well, or if it is giving a very good solvating effect, so it can act as a good plasticizer.
Is it like a test to be conducted, or it is on the material directly?
It is on the material directly. So test you can conduct is like you can see what is the plasticizer absorption value. So for each plasticizer, if you try to use it with different systems, let's say for example, if you're trying to use it with polylactic acid, okay, and if you're using a certain plasticizer with polylactic acid, so you need to calculate its plasticizer adsorption value for that polylactic acid. Means how much gram, if you are putting 100 ml, so out of 100 ml, how much it is getting adsorbed into that polylactic acid matrix. Okay, so you need to calculate it. It is an equation based calculation. You need to do some specific testing, and after that you need to put those values into the equation, and then you get a plasticizer adsorption value.
Okay, understood, sir.
Just a second, just let me see how much of it is remaining. Okay, so we are remaining again with 37 slides. Okay, so uh, so shall we stop here? We will discuss the remaining part for tomorrow, because I have just completed only half portion of it. So if I complete further portion, so there will be very much time left for the tomorrow's lecture.
Sir, can
So
you share the slides, sir, please, today?
yes, yes,
But
I will surely share once I complete the whole this today's lecture. I will share the previous lecture slide also and today's slide also. So total, we are almost half the way in discussing all this polyurethane. Sorry, this polymer additives. We are remaining half portion to discuss. So as today we have discussed it for more than 1.5 hours. Tomorrow also, to get the exact amount of time for question and answer, considering the question and answers also, uh, I prefer going for the next lecture for tomorrow. So can we stop for now?
Okay, sir.
Okay. So meanwhile, if you have any doubt, you can just put as an email to me so that in tomorrow's class I can clear your doubts. Okay. Sandeep sir?
Yes, sir. Yes, sir.
Yes, sir. So for today, I will stop here.
Yeah,
I
yeah,
will
please.
continue with the remaining part tomorrow.
Okay, not an issue. Don't worry, sir. Please.
Yeah. Thank you,
Okay,
sir.
thank you.
Thank you, sir.
Yeah. Thank you.